Matrix Protocol AI Hackathon. I am Aryan Deshmukh from Sri Sant Gajanan Maharaj College of Engineering, Shegaon. We are really excited to be a part of this hackathon. We proudly present a data-driven approach to enable financial inclusion for India's invisible yet financially capable population. In the next slide, we are going to see that the problem and proposed solution. India's first employed are financially capable but invisible to traditional lending. Critical issue in the content of digital lending and financial inclusion. The challenge is to bridge the visibility gap with the data that is available to not traditionally used. Our goal is bridge the visibility gap using non-traditional data. Instead of traditional data, we use alternative signals that correlate with income and repayment behavior. Our solution leverage alternative data sources and machine learning to predict income and repayment capabilities for India's underserved population, like gig workers, micro entrepreneurs, rural households. By combining geospatial, digital footprint, and economic indicator, we create a non-traditional underwriting model that does not rely on formal banking data. I request Atharva to move forward further.
Thank you, Aaron. Basically, in this project, we aim to develop two core machine learning models. First one is a loan repayment capability model, which can predict whether a borrower is a likely repay a loan or not. And second model is a income prediction model, which basically estimate the monthly income using indirect signal, such as mobile usage pattern or satellite data, or UPI transaction like that model, like that 17 parameters. And we actually followed a structure machine learning pipeline. So basically data preparation, model development, and model evaluation, these are the important phase which we follow for the building a model. So in data preparation, we use synthetic data which are generated from UPI patterns, NASA nightlight intensity, and census based features. And income was labeled by the regression model, and repayment eligibility was set using the threshold score. And in model development, we clarify to we use XGBoost for the both regression and classification task. Basically, XGBoost is a regressor for predicting income, and XGBoost classifier to evaluate the repayment eligibility. And third phase, basically model evaluation. And for the income model, we use MAE. We use accuracy, precision recall, and FN score. We deploying the models to the AWS S3 and basically SageMaker for the inference. And finally, we translate model prediction into real-world challenge using Bedrock, like using models such as Cloud A or Titan to just to make a risk profile user friendly. Basically, this slide is a text stack slide, and in text stack, main important to be Python, and Python using pandas, NumPy, scikit-learn, XGBoost, and after building the model Sharp, and basically front end we are using the React Native app using Access for the API communication, and backend and deployment. API were built with the Fast API and deploy using the UVCon. We use AWS Lambda, S3, and SageMaker for serverless hosting and inference. And data generation, we synthesize data using fake, NumPy, random, and signals from NASA and Census API. UPI transaction pattern, added behavior. In short, we combine practical ML techniques with cloud deployment and real-time explainability, all within a user-centric mobile app. The project, which is designed to democratize the credit evaluation using open data and the smart modeling.
So to build these models, we have to identify what is our target. So our target is to build an alternative credit model using non-traditional data. And it should assess these three things: the creditworthiness, financial stability, and intent of the person to repay. So what is the type of data that we are going to collect, and how does it help us in the estimation? So first is digital financial behavior. This helps estimate the creditworthiness and intent of the person. And these are the features that we are going for: the UPI transaction frequency, the average UPI transaction bucket, the mobile recharge amount, the bill payment consistency. So this second is infrastructure and geospatial. So this helps estimate the stability and indirect asset base. These are the features that we are going for. And third is the occupation and economic activity of the person. So this helps estimate the income predictability and the default risk of the person. Uh, Fourth is consumption patterns. It helps estimate the financial discipline and disposable income. And then social and demographic, which helps estimate repayment intent and community risk. So these are some of the data that we are going to collect and how are we going to collect this data. So we are going to collect this data legally and ethically using some privacy first mobile SDKs, and these are the different techniques to collect the different features. So we are basically mainly we are going for the SMS alerts from the person's messages. We are going to notify the user that we have to collect some SMS data from you. So that SMS data also contains the UPI transactions. So this is how we are going to collect the digital financial behavior. For the infrastructure, we are going to use various street maps, various NASA data sets, and these are some tech and the data sets that we are going to use. And the occupation and economic activity should maybe self-declared, or it can be derived from UPI frequency. The consumption patterns will be from SMS and other apps. Yeah, also we can detect the app that are installed on the person's mobile, and then tell what digital description subscription he has. And social and demographic may be user declared. We can take it from public data. Technology adoption, his Android API, his mobile device can be identified. Its app diversity can be counted, and the digital literacy score can be like counted. So that tells us about the financial condition of the person and the amount he's spending and the amount he can repay us. So our collection strategy principles are that we are consent driven. We will always ask for permission. We will aggregate and bucket. We will not use the exact values. We will use the frequency counts. So that helps. We will take pin code level linking. We will be transparent and we will disclose our transparent disclosure, and we will only use client side processing where it is needed. Demo model that we created. This demo model is based on XGBoost algorithm, and this is the data pre-processing and data analysis. And in the end, we train the model on the dummy data set that we created, and then on that data, the accuracy came out to be very good, around 93%. And these are the features that are important, and this is the prediction for some data points. The user workflow for a user can be seen here. And to conclude this, our solution tackles a critical issue in the India's credit system. We have made two machine learning models using the publicly available data sets, and we follow the India's Personal Data Protection Acts and RBI lending guidelines. So we have also created a React Native application using API endpoints via Fast API, and we are going to host this on AWS SageMaker, enhanced further with AWS Bedrock. Thank you so much for watching our project proposal. We hope to work on this and make this better for everyone.